Okay, thank you, and good morning, everybody. My name is Bas Graaf, and I work for the NAV team in Wilbeck. And the last couple of years, I spent a lot of time working on improving the quality of the test automation we use in the application team to test the application. This talk will be quite technical talk. Much time of it will be spent in the development environment. So I hope you're up for it so early in the morning. As a teaser, I will present you this fragment of test code. Well, looking at it, should be quite straightforward what this fragment is trying to achieve. It creates a sales invoice with one line for a certain amount, and then it will post that sales invoice, and then after that, we will verify that the appropriate entries are posted for various accounts. Even though this might seem a straightforward test function, there's quite a few problems with this code. I challenge you to find them. We will get back to it later, and I will just say that there is at least 6 problems with this fragment of test code. So let's get back to the presentation. I will be talking about the features that were added to the product that make it more easy to develop automated tests. These features were added in the release of SP1 2009. May I ask you, has anybody used these features? Can you raise your hand? It's not so many people. Okay. Well, I hope that the others will get inspired to give it a try. As a demo of these features, I will show you how you can apply them to work with a specific way of developing functionality. Excuse me. And this is called test-driven development. So I will show you an example of how you could develop a feature using this approach by using these testability features a lot. Then I will talk a bit about some samples that we put on partner source, and basically it's samples of the tests that we use internally, that we created internally, and some of the libraries and tools, and it could help you get started. I will show you some of that. And the last part of the presentation consists of a section where I take the code that I showed you earlier with all these problems in it, and then I transform it by a number of steps into test code that is high quality, that performs very well, and that is highly maintainable. So let's get started. So I want to talk a bit about what is challenging for us and why we need some of this. So our application that we deliver with the product, we develop the global version of that contains all the global features. This application is around 1 million lines of code. And then what we mostly release, or what is mostly sold in the market, is all the local applications. And they contain the global features that may or may not be localized for a specific market. And they also contain additional local features specific for that particular market. And then we have something like 44, 45 countries, and they add another 9 million lines of code. So there's a lot of code. And also having a feature in the global version for which we have a test case, that means that we execute that a lot against this global version. But now we also want to verify that this feature still works when we've localized it to one of the countries. And that at the beginning that was not so easy actually, because in these countries the data is different, some of the code is different. And yeah, in this presentation I will try to show you what we've done to make this possible. So where did we come from before we had these test features? How did we test before that? We had a lot of manual tests. And after that, we started our test automation with frameworks that were based on UI events. So they would kind of mimic what a user would do, click here, click there, use this menu item, click post, and then go to the ledger, verify something. So we implemented a lot of test automation using these frameworks. And also when looking at the implementation style, it was very scripted, like as a user would do it step by step, without thinking about certain abstractions to make developing these test cases more efficient. So all of these approaches come with quite a few issues. Of course, obviously, manual tests are expensive to execute. You might only do that once or twice in the course of a release, because every time you execute them, it costs effort. The UI-based frameworks, they had a problem that the performance of those tests was typically not that good. And that becomes a problem when you execute your test, like, on every check-in, and you want to execute a large suite, and that takes a lot of hours to execute. Then that's not really possible to do that. Another problem with these frameworks was that they were not AL-based frameworks. They were in other environments, for instance in C#. And then the authoring experience for test code for developers would be not so good because they are used to the development environment, the C-side environment. And finally, there were problems around the maintainability, which had more to do with the implementation style that we used than with the particular frameworks. And also the UI framework, they had a lot of reliability problems. Imagine that Windows tries to update something while you're executing a UI-based test, a dialog pops up, and the control is goes somewhere else, and then your test will fail. So why didn't we start out implementing tests in AL? Well, when you want to implement large automated test suites, there's a few features that you need from a language to support it. So you need a way to execute a test suite and to define a test suite. You need a way to report the results of tests, like in a table. And sure, you could imagine that you would develop something in AL like that, in older versions as well. But then there's a few other things that you need in order to, for instance, to have unattended execution of a large suite. If UI pops up, like a confirmation dialog, then somebody needs to be there to to say yes or no. And we didn't have any feature in the language, in the AL language, to support that. Another problem is that when you test, sometimes an error occurs, but it doesn't mean that you want to completely stop test execution. You want to move on to the next test and execute the rest of the suite as well. And there was no means for doing that. And finally, there might be some application code on page triggers as well, and we also had no way to get to that code in an efficient way. So what was added in SP1? There is something which we call like a unit test framework. JUnit is an example for Java, and there's NUnit for C and C# code. And inspired by those frameworks, we developed a test framework for NAV. And as a lot of good ideas, it's a pretty simple framework. It adds only a few concepts to the language. First, there is the concept of a test code unit. It's like a normal code unit, but instead of normal function triggers, it contains test function triggers. And the difference with a normal code unit is that when you execute a test code unit, it will go execute each test function in it. And if one of the tests fails, it will report that as a failure, and it will move on to the next test and until all the tests have been executed. So that was added. So now we have a way to execute tests and deal with failures. Another concept that was added was that of a test runner code unit, which is used as an integration point. So when you execute a test from a test runner code unit, then you have an opportunity to do something just before a test executes and something just after a test executes. And I tried to illustrate it in the figure you see here, what the control flow is like when you execute a test from a test runner code unit. So the pattern is that you have a non-before trigger, which executes before each test, and then the test executes, and then the on-after trigger executes. So in the on-before trigger, you can do stuff like deciding if you actually want to execute the test that follows. You think about an UI where you have you enable and disable tests, and then this test runner gives you an opportunity to implement something like that. I will show you an example of a UI later. And then in the on-after trigger, you have the possibility to record the results of a test in a table somewhere, and then you can generate a report later to see your test results. So that's the test runner code unit. And then related to the few problems I mentioned, there is now a means to handle UI. So you can define a function that will be called whenever a message dialog or a confirm dialog pops up. And then you can define in that function what should happen. Should I click yes? Should I click no? Will I just confirm the message dialog? And you can attach these handlers to the test functions where this UI might occur. And then there is the opportunity when you do test automation, you don't only want to test positive outcomes. Sometimes you actually, in some situations, a certain action should fail. And then you want to assert that an error occurs. And the concept that was added was the error assertion. And I will show you examples of all of these things later. And in an upcoming release, in NAV 7, we will also add the opportunity to interact with pages via a new object type, which is called test page. And I will not show you that now, but in other events you will see demos of that. So let's go to the first example of how to use this. There's this book written by Ken Beck, pretty famous software engineer, and he introduced or reintroduced this approach of developing product code by starting out with writing the tests. And sure, intuitively it sounds a bit weird to write tests before you write any product code, but I will demo you in a few seconds how that works. And the essence of this approach is that you write a test, and you have very short cycles between write a test, make it pass, write another test, see it fail, update the code to make it pass, and then you have a very short cycle that allows you to take very small steps that you can always go back if you make a mistake. So the cycle starts with you check your requirements, and then you pick one, and then you define a test that, if it passes, verifies that you've implemented that requirement. So you add that test, then you run it, but since you haven't added anything to the product code yet, that test will fail, of course. So the next step is to make it pass, and then you check that it passes, and then you start again. So you select your next requirement, you add a test for it, and you go on like that until you've covered all your requirements. So as a demo, I will add a simple feature to NAV, and in this feature, which is, I think, in a few localized versions, this feature already exists. It's an amount field on the purchase invoice that specifies the total amount of all the lines. And when you post and that total amount does not match the amount of all the lines, then you will get an error where you say, okay, you need to check this amount. I think it's a safeguard for posting, like where you displace a comma somewhere. So I think it exists in the Dutch version, but it does not exist in the North American version. So I will now in the demo I will try to add that using this test-driven development approach. And in my ear I hear Lars whispering, "Why don't you just use DevBase for this?" But the point of the demo is to show you this test-driven approach. So I said that we would start with adding a test. So first thing you need to check is whether you have the testability features enabled. And you can find it in this option panel. So yes, they are enabled here. So that means that in other properties on code units, you will get those testability features to be visible. So let's add a test code unit. So I say, well, let's give it an ID and a name. I would call it test document amount. And then here I would say that it is actually a test code unit. So done that. And then adding the first test. So then you need to consider a bit the design. So we talked about a check whether the total amount on the lines matches something that you specified on the header. So what you would need at least is some function that will calculate the total amount. So how would you test that? Well, the simplest test for that is that you take a purchase invoice with one line, and then you have it calculate the total amount, and then see if it matches what you put on the line. So when you define a function on a test code unit, that function by default will be a test function, as you see here. And now I can just implement it as regular AL code. So, well, we would need a purchase header and a purchase line. So let's define those. So that's 38, yes. Sure, so let's create a header. And another thing with test-driven development is that you always do the bare minimum with what is necessary. So I will skip all the initializations. I will just insert a header to get a document number that I can attach to my line. And then I will give this line some line amount. And now we need to actually call something that we haven't implemented yet. So I would imagine that we would implement it on the purchase header so that you can say to a purchase header, okay, what is your total? And then you want to verify that it corresponds to, well, basically this what you put on the line here. And in unit testing, you use assertions for that. Assertions, you typically have them in the end of a test, and they kind of verify that whether your test passed or not. And in this set of samples that we made available, there's included in there is an assert code unit, and I will just use it. But you can, of course, also roll your own if you want. And what it does for you, that you can say things like assert are equal, and then you start with your expected value, which is 1 in this case, and then the actual value is the thing that the purchase header will calculate for you. And then for the sake of being able to distinguish between different assertions in the same test, it is a good idea to give it a message about what this assertion was about. So I would say, okay, this was about the document. Okay, surprise, surprise, we haven't implemented this thing yet. Unfortunately, there's no magic here. So I will just save this and back out. And then I go to the purchase header. Call doc amount. That's what I said, I think. There. Save. So let's go back to the test. It should compile now. It doesn't. Because the doc amount should return the amount. And I forgot to add a parameter here. Return value is decimal. Save. So now my test compiles, and I think, okay, now we should implement this functionality. Now, first we need to check that the test can actually fail. So, and we can check that by running it now. And now you can also see the UI that you will get from running a test code unit. It's a dialog that says, okay, there was one test, one line, it failed, and the message is that the assert error, the assert are equal failed. I expected 1, I got 0. And it was about the document. Okay, failure. Yes, remember the flow of test-driven development. Add a test, see it fail, and then add product code to make it pass. So I go back to the purchase header, and now I will add some implementation here. So one of the things with test-driven development is that you always do just enough, never too much. So what is the easiest, quickest way to make it pass? Well, okay, we need to check which purchase lines are in this header, and then we need to add the amounts, and maybe, but actually the simplest way to make it pass is this. Let's check. Oh. Yes, success. Okay, of course, you think, what is this kind of a weird approach to make something pass? But actually this is allowed. You can commit any kind of sin to make a test pass, because it will be corrected by itself later when you add more tests. For instance, when I add another test which puts 2 on the line, then I cannot return a constant anymore here, right? Because then I need to be flexible, and I need to abstract a bit from the amount. So you can compare it to, in geometry, you have this triangulation, or driehoeksmeting in Dutch. So when you start adding tests, the functionality gets more and more defined. And the point with test-driven development is that the functionality is completely defined by the tests that you create. So let's go back to the test code unit, if I still have it. So what I could do is add another test. Oh, I will take the easy route. I will just copy it. So what I could do is, I say 2, and this will fail. But you could say, okay, then you can make some kind of check, and then if it's 1, you return 1. And so looking at this, actually, this 2, you don't really care about this 2. And it is sometimes a good idea to make that, to express that. So how can I express that? I can express it like this. I can say, give me a random number here. And then it will be much more difficult to fake it in the implementation. So instead of checking 2 here, I would just check what I've put on the purchase line. Because that's my expected value. Oh, and I also see that I forgot to insert it, actually. But probably you've already seen that. Okay, so I added 1 test. Now go back to the to see what happens. We should see it fail. Failure, sure. So apparently it selected 51 and it returned 1 because we return a constant. Fails. Let's switch back and add some implementation to make this one pass again. So now we actually have to do some work. We should have a look at the purchase lines. So I add a variable for it. Yes. So what we do, we will filter for the purchase line that has the same document number. And then we will find it. And then we just return the line amount, because in case we have a single line invoice, that is what is the total amount. Okay. So the next step in the cycle is to run your tests again. Now it passes. So now we have 2 tests. Let's do a few more. So actually looking at another step in the cycle is that you always end with a refactoring step. So, and it can be the code, but it can also be the test code. So in this case, I conclude that having this test now with a random, I actually don't need this one anymore. So then I just remove it. So the obvious next step is, of course, the requirement would also say that this should also work for a multi-line purchase invoice. So we added a test multi-line. I will be lazy again by copying it. Now suddenly also the line number becomes important, because you cannot add 2 lines with the same number, obviously. So by convention I will take this number, and now it's easy to create another line with the next number. So then the question becomes, what will be my expected value here? It will be the sum of these 2, but we don't know what they are. We could add it, but considering the fact that we already have this one here doing random, I would say we can do it a bit easier and just pick a constant here, then I would advise you to not pick the same constant here, because then it will be hard to understand whether you've counted this one twice or that you actually added the two different ones. So, but if you select a different value here, then you circumvent that problem. So now we check 3. That's the expected value. Let's run it again. Yes, we have a failure. Of course, you've already seen why it fails, because we only look at one of the lines here. So we should find the set in this document and then loop over them and accumulate that in some kind of total. Until we have no more. And then, of course, we return the total. Yes, we need to define the accumulation variable, which is decimal. All right. Did I save it? No. Run my test again. Success. We are green. I will do one more, or 2 more maybe. So going back to what we intended to do is we want to have a check that you could, would fail an attempt to post a document. So somehow there should be a possibility for this to fail. So let's make sure that it can actually happen by adding a test for it. We call it fail. I consistently forget to just copy. So, but for this we need to think design a bit more, because just calculating the amount will not do it. So we need another function on the purchase header that will fail if these amounts do not match. That is the document amount on the purchase header and the total of the lines. So I assume that I will have this one, and I will call it verify doc amount. Then I don't need this anymore. Yes, that reminds me that I should implement it here now. Just add that function. Okay, so how can we make this test pass? The easiest way to do that is to throw an error. And we would say, remember to check your document amount. Oh, I need to save this one. And therefore I need to close it first. And now I can compile it and run it. Hey, it fails. But that makes sense because we actually wanted it to fail. But in this case, failure means that the test passes. Right? This is an example of a negative test. So here is where the failure assertion comes in. And the simple way to do that is that we basically, by doing this, we say that we expect that in this statement a failure occurs. And that's the desired behavior. So the test should pass. So now we have a passing test again. Of course, obviously, this is not the end result. So we can triangulate again and add a test that is, I would call it happy. This is the happy path. This is kind of the standard path. So you create a purchase invoice with a line. You verify the amount in the document amount field. You post it, and it works because the amount matches. So I can just copy this one. I call it happy. Actually, I forgot to force this into failure by putting another, by setting the document here. And I hope I will not confuse you by doing this. This is the actual trigger for the failure condition. The document does not match the line amounts. And in this case, in the happy scenario, we want that to match. So we put one there, and then we put one here. And then we, of course, not expect this to fail. So this is now the expected behavior. Yes, thanks. So of course, yeah, I haven't defined that field yet. So, but you know, that's not, I like programming by having the compiler tell me what to do. So we just add it in the table. Save it. Now we can compile it. No, I made another mistake. Yes, thank you. And another one. That's a problem when you copy paste. Right, run it. So now the happy path fails because we forcibly returned an error there. So to conclude this exercise, we fix that as well. So when should the error occur? The error should occur when the document amount is not equal to the calculated document amount, which accumulates the lines. So now we have all green again. And you can continue this, adding test cases for what should happen if it is not an invoice, what should happen if you have no lines, and you can continue that. But I hope you get the idea. And also, please understand that I took deliberately very, very, very small steps in this example. And when you apply an approach like this, by time you will take larger steps, and suddenly you might become too confident at some point where you take too large steps, and then you will backtrack again, taking smaller steps. It's a flexible approach in that extent. And also note, I'm not saying that this is the best approach. I'm just saying that with these test features, they enable working like this if you want to. So now I would like to show you some of the stuff that we put on Partner Source. And as I said, these are like examples of things that we use internally. Some of the tools and library functions that we use to develop our test automation. So what does it contain? When you download it, you get a zip file. You can extract it, and then there's a FOB. And it contains a test case management tool, which is basically a UI in the rotator client to run your tests. I will show it you in a minute. And there's a lot of test utility functions, like the assertions that I already showed you. There's a code unit that helps you with restoring and backing up data so that you can always return to a known state in between tests. There's also a lot of helper functions that help you with creating records, like create a customer, create a sales header to make that easier. And then there is over 200 application tests that we run multiple times a day, and various areas such as finance, inventory management, and service management. You should check it out if you want. So now let's show you the test case management tool. And now I will first check whether my server is actually running. It is not. Now it is. Oh. Let's run it. And this is based on this test runner concept. And you can use it as an example, but you can also use it as is, or you can create your own. Yes, hello. Yep, there I am. So now it's inspecting the object table for any test code units. And I already imported this toolset, so all these 226 test code units are there. They should be there. Still thinking about it. So now I have this, and it will place all of them in a default test suite that I can open. So this is some of the tests that is included. And look, here's also the test we just created. And then you can expand it to see which tests are there. And then you can run one test like this. Success. And this is the green I was talking about. The mantra of TDD is that you do red, green, so you make a test pass as quickly as possible, and once you're green, you start refactoring by improving the code. But that's not dangerous anymore then, because you have this test, and you can just run it again. So you can also run a whole test code unit. Right, and then you can run everything in a suite, and then you can enable and disable individual tests, and you can run tests while the debugger is enabled, and then debug tests. And so this is pretty similar to the functionality you have in any test framework. Okay, let's go back to the slide. So it's available from partner source, and I think it's also, I saw it on Mobuso as well. I showed you this. Assertions, as I said, so you use them typically in the end of a test to verify the outcome. And if the result of a test is not equal to the expected result, then the assertion will fail the test. And here's some examples. The assert is true is a very simple one. You just give it a condition. So in the example here, you might have posted a purchase document, and then you want to verify that it has been removed, the record. So you assert that purchase header that it is empty, and then if in case of a failure, you give it this message: PO should have been removed. And then when it fails, it will show you the message indicated in red. And then there's an assert is false, like to do the opposite, are equal. You already seen that one. And there's, we've also added like an are nearly equal, to deal with rounding differences. And you can come up with other types of asserts as well. Then a thing which is kind of important when doing test automation is that is how to deal with the test data. So when you run tests, your data changes. And when tests fail, you can end up in a situation where your test cannot run anymore because, one test deleted all the items or another test removed some posting groups. And to get out of a situation like that, you would like a way of restoring the data to a known state. And included in the application test toolset is this code unit implemented in AL that you can use to do that, exactly that. So the interface of this code unit contains a function default fixture. I want to notice that the term fixture is used in when looking at test automation to denote everything that you need to put in place for your test to run. So for instance, if you are posting something, there needs to be certain things in place, like posting groups, that you need to have a customer, you need to have an item, stuff like that. And this default fixture gives you the possibility to set that up manually, and then when you test run, the first time it is called, it will create a backup of that. And then the next time it is called, it will restore the backup that it stored. So when you make sure that you call this function in each of your tests, then you kind of guarantee that each of your tests execute against the same data set. So this improves stability a lot. It also offers, more detailed ways of backing up. You can back up individual tables and then restore that from a named backup. For instance, if you know that your test only modifies a few specific tables, then you could focus only on those, and then your test will perform much faster if you need to restore those later, instead of restoring the whole database. So in the next section of this presentation, we go a bit beyond just the use of these test features. We also will be looking at some best practices and bad practices around implementing test automation. And for us, the need to implement these practices came from a number of problems listed here. So a big problem for us was, since we code our tests against Cronus demonstration data, sometimes when this data set changes, and it changes sometimes when we update maybe currency rates, or items might be removed, and also think about that in another country the data set might be different because there might be a different chart of accounts. Customers might be different. So we had a hard time implementing tests that would be resilient against that. Also, because the way we scripted our tests, they were pretty difficult to understand. They showed unstable behavior. The execution was pretty slow. And as I said, dealing with a localized application was pretty complicated. So now I will present the approach that we took when authoring tests, which is based on patterns. So we have bad practices, and we refer to those as smells. So we have a number of named smells, like a well-known example is duplicated code. It's a smell because it can lead to problems later. And we have a number of those. And at the other end of the spectrum, we have best practices that we refer to as patterns. So a good pattern is, for instance, to instead of duplicating code for the creation of a sales invoice, you could create a function that will do it for you, and then you just create that function. And by naming these smells and patterns, it gives you like a vocabulary that you can use when reviewing each other's code, or when talking about certain problems and how to solve them. And the result of applying the good practices is that it leads to test code that is data agnostic, which also means for us, very important, that it is language agnostic. So it should allow us to execute tests against different data sets or different countries. It leads to tests that are much more maintainable, because the way we implement them is that they become self-documented. So you can understand all the elements of this test by just reading the code. And I will show you that later. And also, they will execute much faster. So to illustrate this, I will use this example, which is a valid test case. It could be one of our test cases that started out as a manual test case, and it could be specified something like this. And it is kind of similar to the fragment of code I showed you in the beginning. So in this test, a new invoice is created for a particular customer, and it posts against a certain inventory account for a certain price, and then in the end we verify the ledger entries in the receivables account and the inventory account to be as expected. And then we might have a variant of this test. What happens when we try to do this, when we post to a blocked inventory account? Well, then you would expect that the posting would fail and that there is no ledger entries created. So we were looking at these two variants, and then we will start out with a very naive implementation and then move gradually to a better implementation. So starting out with smells. So this is the same fragment. And I promise you that there's at least 6 problems. So maybe you've seen this one. It contains hard-coded test data. Why is this a problem? Well, you cannot execute this test in a data set that does not include customer 01905893. Then it doesn't work in a localized country where account 14200 does not exist, because there's a different chart of accounts in that country. So that's an obvious problem here, and it reduces the value of this test because we cannot execute it against different data sets. Then a more subtle one is that, it might not be so obvious from this one, but if you have more complicated test cases, you should try to only show information in the test function that is relevant, that is needed for understanding the purpose of a test. So as an example, in this case, setting this line number to 10,000 has no meaning in the result of this test. So it should not be shown here. It should be abstracted away. And it will be shown later how to do that. And this is one of my favorites. It's called Mystery Guest. And to explain the name, if you look at this account number of 13200, by reading the code of this test, there's no way you can figure out where it comes from. In this case, you might know that where this particular customer is, but you cannot tell that from reading the code. So this code is not self-documented. And the same goes for this amount of 8.22. In the test itself, we had this amount of 9.95, but now here we have 8.22. So it could be some kind of VAT calculation. It could be a discount. I cannot tell from reading this code. This one is not obvious by looking at this test alone, but you can be sure that if you, create other tests, they will also need to create a sales invoice, like the variant where you post to a blocked account, and then very fast you will have this code duplicated all over the place. So that's 4. I promised 6. So there's 2 others. But let's first talk about this mystery. So this is kind of how posting an invoice works in my mind. And now you can see that because this specific customer is part of the foreign posting group, it posts to a particular account, and that's where the 13200 comes from. And now you probably also see that since this is a foreign customer, there is some currency calculation done here. So this Canadian dollar is converted into US dollar, and then the exchange rate makes that the amount is different. And that's where it comes from. But you couldn't tell from reading the test. And you couldn't even know that this is actually relevant. Are we testing a currency conversion here? The test doesn't tell me that. So the other remaining 2 smells, you can best show them by actually running that test. So let's go back. I imported those tests here. For the sake of there might be small differences, but that's just for the sake of the demo. So this is the first one that tries to post to a block account, creates the header, creates one line, and then it blocks the account that is posted to, and then we assert that the posting will fail. That happens here, and then we also assert that there is no GL entries created for the receivables account, and that there is no GL entries created for the inventory account. And then finally, we also, as to be nice to the following test, we also put this account which was blocked to unblocked again. And here's the other one that where the posting succeeds and where we verify that the correct amounts are posted. Okay, so very straightforward, you would say. I could run it. Yes. Now I'm surprised. Okay, sorry. I should have run it in US. I can run it. Just pretend you never saw the other one. Okay, so it passes. All fine, you think. But now what will happen if I run it again? Oh, I run again the same test and now it fails. That's not so nice. If if you saw the short cycles of coding, running tests, coding, then you don't want to restore your database after each change that you've made. So this is one problem. Then the other problem, and I already revealed it, but if I go to Canada, which is basically the same as saying that now I try to execute this test on another data set because there are slight differences, even though the application code is exactly the same. There's no difference between the application code in US and Canada. When I run it here, it also fails. So to go into detail why it fails, so in US we had it failed the second time. And why is that? That's because when we do this the second time, there is already an entry created for. So when we run it the first time, the ledger entries are created in the second test that succeeds the posting. Then when we run it again and we try to verify that posting against the block account failed, then these checks they fail because the entry was created in the previous run, and we didn't clean up the database. In the case of Canada, there the problem is that in Canada, this customer is not a foreign customer because it's a Canadian. So then we will not have actually this account that is posted to because it's not the foreign posting group, because it's not a foreign customer in Canada. And at the same time, we will also not have this currency conversion because it's local in that case. So there is no currency conversion in the Canadian case. So this shows you the, two other smells that are also summarized on this sheet. So we saw 4 code smells, and code smells you can detect them by looking at the code. And then we had 2 behavioral smells. One, we saw an example where the second test interacted with the first test in the second run, and one where we saw that there was too much data sensitivity. So the test depended on the fact that this customer was a foreign customer, which it wasn't in the Canadian case. So let me check the time. Okay. So now I will show you how to improve this code step by step by applying best practices and removing these smells one by one. So I will start here. So the first one is obviously to conclude that we have this code here and it's duplicated here, and we can apply a certain refactoring where we extract a method out of it. So and to help you guys and to show you the value of something where you create such methods, actually a method like this is included in the application test toolset, which is available on Partner Source. So I can just pull it in a certain library, and I know that it's in the SCM library. And let's see what is in that library. So you see that there's all kinds of creation functions in there. And then you can reuse them over and over again every time you need to create something. And luckily, there's also one to create a sales header. And then here in the bottom, we can see what parameters it requires. So there's an output parameter, the sales header that is created. And there are 2 input parameters, the document type, which would be invoice, and the customer number. So let's use this one to create the sales header in a much easier way. What was it? Document type. And the customer number, which is specified over there. Note that we were still using now hard-coded values, but we will get to that later. So we also need the sales line. So let's see. There's one for that as well. And it will give you back the sales header and the sales line, and it requires a line type, a number, and a quantity. So let's do that as well. I said line type, so that's We were posting to a geo account. Number was 14,200. And a quantity, we don't care about it, but let's put it to 1. So now in these two lines, we actually create the sales invoice. There's one thing missing though. We haven't specified this amount. So, we can, it doesn't happen in the creation function, but we can do it inline here. So, and that's also a very common pattern, that you use a generic creation function and then you will tweak it a bit to create the records in your test itself to have them as you want them to be. So, and then this will be a modify. Okay, so now we can remove this stuff as well. Okay, so it looks a bit better now, but we would still duplicate this as well to the other one if we want to create the sales invoice there as well. But just don't do that for now. So let's try if you can reduce this even further. So we would still have duplication. That's one thing. And on the other hand, it's still we were talking about this specific customer. But when looking at the verification, the only thing that is relevant here is that it posts to this account. So we don't care about this customer. The only thing we actually care about that we select a customer for which we post a sales invoice, that it posts to that particular account. So let's imagine that we have a function that will create a sales invoice. And it returns to us the header and the line. I will do that in the end. And so what do we care about? Okay, I said that it should post to a certain receivables account, this one, because that's the one that we verify in the end. And we also verify the amount, so we also care about this amount. And then we just, basically say, okay, go figure it out and just return me a sales header and a sales line that, satisfy these requirements. Okay, so this is what we want. There's still no magic, so we have to define it ourselves. In the code, okay, thank you. Oh. So remember that if you have a test code unit, when you add a function, it will be test function by default. And this is actually not a test function, it is a helper function. So we will set this one to be a normal function. And a good practice is also to, when you have your test code units, that the helper functions you define in those, that you make them local. Because otherwise you will get into a situation where all your test code units depend on each other. And then you will never be able to just give out a single test code unit to a customer and say, okay, can you run this or something like that. So we will always make that local to prevent any dependencies between test code units. We gave it a few parameters. So the first one was the receivables account number, which is a code of length 20. The second one was an amount, decimal. And then we said, okay, we will give you back the sales header and the sales line. Okay, let's try to implement it. Well, what it will look like is that, well, it will probably look a lot like this. So let's just put that in there. And now we just need to change a few things. For instance, we said, okay, we will not hardcode this customer anymore, but we will say, give me a customer that posts to the receivables account that I specified on this helper function. How do I find a customer like that? in this case, we decide not to search for one in the data we have. I will say, okay, we will create one. So I will say, create me a customer that posts to this receivables account number. So we just pretend that we have this function. And then what's happening here, here we have a hard-coded this GL account, which we also don't really care about the specific account. So let's say, for the sake of example, to also show you a finder function, which is another pattern, that we will say we will find a suitable account somewhere else and use that. This one is okay, and then the 995 here is the amount that we specify when we call this function. That's all there is to do here. But of course, we defined two new functions that we haven't implemented yet. So let's add that. First was create customer. Remember to say that it is not a test function and that it is local. And we also said that it takes a receivables account number. And that it returns a customer number, which is a code of length 20. So probably we would need a customer variable inside. Okay, let's go implement it. So it creates a customer. Well, the easiest way to create a customer is simply say init and then say insert and then return it, the number. Okay, but wait a minute. So this is not the customer that we were looking for, right? Because we were looking for a customer that posts to this specific receivables account. That is controlled by the customer posting group. So how do we go about that? We can create a specific posting group specifically for this purpose, but then you end up in the area where you need to define all these accounts on this posting group in order to use it for posting. So what I will do is I would just take a posting group from the ones that are already defined, for which I know that they work, and then we'll just update that receivables account number. So which customer posting group will we select? Well, actually we don't care. And a nice way to express that is to do it like this. It might be a bit dense, but actually what this means is, this means is that, you know, move a random amount of positions forward, but no more than the total amount of records in the customer posting group table. So this will give you a random customer posting group. The next thing to do is, well, let's define the variable. Actually, I forgot that. Oh. Does any of you know which number it is? It doesn't matter. Okay. Yes, I'm getting sloppy here. Thank you. Okay. So now we need to set that this actually is posting to that particular receivables account number. And let me be lazy here and just do it like this. So, and then we modify it. And then don't forget to assign it to the customer. And modify the customer. So what we have now, so we created a new customer. We updated one of the posting groups to set it to the particular receivables account, and then we attach that one to the customer that we created and return it. So this should work. What's there left to do? Oh yeah, we also defined this find GL account, and it should give us back an account, a suitable account. Let's define the function, finder function, very useful pattern. Remember, it's a normal function and it is local. And it should return the account number, and that's a code 20 as well. So then we also need a variable to be able to return it. So we can, of course, start out with the same pattern. Next GL random GL account. And then exit the account number. Sure, but we might, in this case, need to be a bit more specific about the account, because if we select a random account out of all the accounts, then the account might be blocked, or the account might not be a posting account. So to take care of that, you can just set up a few filters saying that it should not be blocked, and also saying that it should allow direct posting. And finally, let's make sure that it is a posting account. So by setting up these filters before, we are sure that we are only searching in that particular set of accounts, and that we actually return a suitable account. So probably I forgot semicolon. Okay, very good. Almost there. I'll go back to the top. Our create sales invoice is finished. It will create exactly the sales invoice that we want. So now we need to update a few things here. Let's see. No, this is still right. Okay. So there's one final thing, and that we still are hard coding this account. And remember that this account might not exist in another data set, or it might not be the account that the particular customer posts to in another data set. So let's get rid of that and find or create an account. In this case, I will choose to create a GL account, also for the sake of demonstrating you a few more patterns. And we actually want that account back. We want a handle to that account, because then here we can block it. Right. So this would be a normal function, again, local, and it would take a GL account to return. And the actual return value is also the account number. This is also a pattern used a lot, where you actually return the account as a var, because then you have a handle to the account that you can use later. But also to actually also return the key directly, so that you can use it in in this kind of syntax. So how do we create an account? Well, we could just say init and then set a number. Let's call it test account, and insert it and return the number. Okay, actually this is not such a good idea, because if you call it another time, then the account already exists and you have a duplicate, and then it will fail. So we actually have to make sure that we insert an account that does not exist yet. So we have a distinct one. How to do that? So say we let's remove this. Say we filter to see whether we have accounts that comply to this pattern. Anything that starts with test account. And in case we don't have such accounts, then it's like the first time this thing is called. Then we will initialize this number to this. And then after this, we can really insert, initialize the account number for the one that we want to insert to being either one up of the last one that we created or one higher than how we initialized it. So this way we can be sure that we will not be inserting duplicate accounts. And also when you execute your test, they are pretty recognizable in your list of accounts that this is a result from executing these tests. Okay. Is this done? Well, let's be safe here and also initialize the other fields. Okay, so now we got rid of that final hard-coded value. We just need to be careful that this account is now actually the account that was created, and we got it returned. So we put in the account number like this. And this account is also not 14200 anymore, but also kind of randomly selected. But we know it because we have the sales line here. So we can do that like this. So now let's push out this solution also to the other test. And update the same thing here. It is not this static account anymore. Ooh. But it is the one that we created. And it reminds me that I need to add this variable here as well. And this one is the one we had on the sales line. So no static values here anymore. The final thing to note is that about this actual value with the exchange going on, since we now are creating a new customer and we haven't, updated whether it's a foreign customer or not, it will be a local customer that we can create it ourselves. So we don't need this conversion anymore. We can just put in a 995. And now it's also immediately clear where that comes from, because it matches the 995 here on the top. Okay, so now these test functions, they really only contain information that you need to understand the purpose of these tests. And as a demonstration, let's go back to US to see that it runs. Did I make a mistake? Minus, thank you. It runs, and it runs again and again. So that, now it works a lot better. On Canadian, where it also failed, it also runs, and again, and again. Okay, so just maybe one more thing I want to show you regarding this. You might think, okay, this is a lot of work. Yes. If I show it like this, it's a lot of work. but you can also choose to to implement it like this in the first place. And another thing that is a big benefit of this is that now it will be very easy and cheap to add additional tests that are slight variations of this. For instance, this test posts to a normal account and another test posts to a blocked account, but you could now add tests that posts to an account that doesn't allow direct posting. You can add a test that tries to post to an account that is not a posting account. And to do that, we slightly modify the approach. We change this in a helper function, like this. That may be local. And then we can add a few parameters. So we can say a blocked Boolean. And we can say allow direct Boolean. And these are kind of the test parameters. And then I also set account type. And now I could add, for instance, so this is the normal one, posting. And then I can add one post to blocked. Oh, we already have it. A post to non-posting. And I can add post to not non-direct. And let's first convert this one using the parameterized test I just created. So I could just say here post to GL account and then say, okay, I want to post it to blocked. So I block this through. It allows direct posting and the account type is a posting account. So now I need a hold of a GL account. So I just define this dummy const GL account to do that. In order to get to that type. And remember that when you try to do this, you actually expect that an error occurs, so we assert the error. And then I can easily, extend this, saying, okay, this one is not blocked, but it is allowing direct. It is not allowing direct, false. And in the same way, post to a non-posting account. So that's an account that is not blocked, allows direct posting. And let's say we will just try a total account. And then this is what actually the one that we originally already had. And this one allows direct posting. Now there's a few small modifications to be made here, because we need to say that the account that we've created here, and then we need to do, parameterize it according to what's passed in here. So then I would just say and modify it. So now I have, very quickly added 2 more tests. So if you find more parameters, you can very quickly extend. And this is actually made possible by using all these patterns. And this is actually a pattern we use a lot in internally in our application team. Yeah, I'm a bit afraid to run this. I think I made a mistake, but okay, let's just try it. We get a confirm dialog. We want to handle that, and I will show you why that doesn't work. We get 2, 3. Okay, so it seems that the posting to a non-direct account is actually allowed. But let's just explain why the confirm dialog now pops up. Notice here that, and I kind of didn't show it before, that we have a function here which is named invoice confirm handler, and it gets a question of type text passed in, and there's an output var reply. And actually this one is called when a confirm dialog pops up, and then it sets the reply to true, and that the platform will confirm the dialog, and it will disappear. But in order to enable this, you have to attach this handler to the test functions where this UI might be raised. And I didn't do that when I added these test functions. So if you look at where to do that, you go to the function pane here. So here it's undefined. Do I have one where it is defined? Yes. So here you have a reference to the handler that I showed you. So when I just copy this here. So now I've attached the handler to these functions as well. And the platform will make sure that when the UI is raised, that the handler will be called. And we also noted that this should actually be allowed. Okay, so now we have 4 passing tests. And it's kind of, when you add more parameters, it's a multiplication. So if you have, you can add, it can be blocked or non-blocked. So there's 2 options. Then for the account type, you might have 3 options. And then for allowing direct or not, it's another 2. So you get 2 times 3 times 2 possibilities. But it now is really easy to implement all those. All right, so let's go back to wrap up. So now I had some kind of backup slides if the demo wouldn't work, where I would walk you through all the patterns, and we've seen most of those. So this is where I ended with the parameterized test. And this pattern, I didn't call it out explicitly, but typically a test consists of 4 phases. One phase where you set up the data for it to be to make it possible for the test to pass. Then there is a phase where you where you exercise the system under test, where you actually call what you want to test. Then there's a phase where you verify that the result is as expected. And then the 4th phase that is not always there, but you might want to clean up some stuff for tests that come after this one. So we saw these guidelines that test functions need to be local and that you can wrap creation functions if you need something specific. This is some interesting data about different approaches that you can have regarding restoring the database, restoring the test fixture to a known state. And we tried different approaches internally. We started out by recreating all the test data, the demonstration data after each test. And we use a tool for that, and it takes 2 minutes to execute. So we had a restore time of 2 minutes in between each test. Then we had an approach where we could, based on this backup system, where we could create a backup and then restore that. That was faster. It took 25 seconds for each test to do that. But still, it's way too slow to have a very quick cycle of testing, adding code, testing. So then we defined a guideline that we would only do this for each test code unit. So then the tests within a test code unit, they would not be, let's say, independent, because they would execute on a shared data set. But then between test code units, they would be independent and separate. So of course, then you restore much less. So for instance, at that time we had 5,000 tests in 400 test code units, and then we would only restore 400 times. Using the 25 seconds per restore, you come to something like 2 seconds per test. we optimized it further, where we said, okay, what we can also do is just, as long as we keep running tests and they keep passing, then we just don't bother restoring at all. We only restore when we find that the test fails, and then in order to figure out whether it failed because the data set became that polluted, or whether it failed because of some bug, we restore the data at that point, and then we rerun the same test again to make sure. And in a typical run, we had 20 cases of this where a test needed to be rerun in order to check whether a failure was real or not. And then when you calculate the average execution restore time per test, it was only 1/10 of a second. So taking it even to the most extreme, if you can code your tests in a way that they are completely independent, then you could say, okay, then we just do it once for running the entire test suite we have. And in this case, it was 5,000 tests. Then it would only take 5 milliseconds. So we're not doing that, but just to say that the different strategies that you can choose, they have a huge impact on the performance of your test suites. Regarding when to execute tests, we have different patterns of that, basically in different layers. So developers, they execute tests locally on their machine before they check anything in. In the next level, then we run all the tests when we check in code. So we have a check-in system that compiles, but also runs a whole suite of tests. And then when we create intermediate builds, we execute even more tests in the test lab. And then there's also tests that, even more tests that we run on a regular basis, but then weekly, for instance. And it depends on, the size of a project, what levels do you need. Because the app is pretty big, we need to execute tests as often as possible. So this gives an impression of comparing to the old approach where we used these UI frameworks that were not that well performing, the difference in performance. So before, for instance, we had 1,500 tests, and they would execute in 80 minutes and in our test lab, and they would use 60 machines to do that. And after, when we converted those tests to 4,500 AL tests, and they don't map one-to-one, but they have a similar coverage, we could execute those in also 80 minutes, but then on a single machine. So you could say that it's already a 60-time performance improvement by switching to an AL-based solution of testing. So before we move to the questions, some key takeaways. So developing tests like this, it's definitely not easy, but I would say that going for a straightforward approach, in the end, you will be hit by it, because then it becomes very expensive to maintain those tests. And also, when you get the hang of it, I would say that the approach where you have a much more structured way of developing your test is much more productive, because reuse opportunities are much higher. And it's really the only way to keep large test suites manageable and maintainable. And of course, final question is, if you don't need a very large test suite, then you could question, do I actually need all this? But of course, that's for everybody himself to decide. So these are some references. Information on the NAV test features is on the MSDN documentation. And then some of the concepts I explained, you can find more about those in these books. On refactoring and the specific test patterns, but also on the approach where you have the test-driven development cycle. So yeah, that's it for me. I think we have a few more minutes for questions. There will be a mic. Yes?
Compliment for your presentation. 2 questions. One is, as you say, your figures about optimizing the processes, so not reloading for every few suit. You might run into passes or tests that pass because you didn't reload, of course. Did you have any experience on that?
Yes, and so basically, when you only rerun these tests in case of a failure, then at some point you can get in a situation that tests actually pass because something before it changed the state. And you could say that's a risk that we take, and sometimes we are hit by it, and then, but it's a trade-off. But definitely, you can run into problems like this, but we need the performance.
That's theory. What is your experience? You haven't run into that, or you ran into it very, no, not frequently?
It happens, like, let's say, like every week once, or. But remember that we run all these tests on each check-in, so that's like 10 to 20 times a day. So we run them a lot. Yeah.
Second question is about the application toolkit as such for local applications. Is there any plan yet to release? Let's say you have now released a set of 226 tests, but it's W1. Most of us are working on local versions, and now everybody is inventing the wheel themselves to get it working on the local version. So what is planned from Microsoft's side to release the set of 226 localized?
Yeah. So the tests that are on partner source, they are verified to work on, I think, Germany, North America, and Denmark. I think. I'm not quite sure. Regarding the plans to move forward with this, also internally, we're now starting, to add more tests and to enable them for all the local builds. So, when we finish that, of course, then it will be also easier for us to take another sample of those tests that run on multiple local builds and to put them on partner source. And I expect that we will do that, but there's no concrete, plans when we will release that. But the intention is to have a release like this, together with each major release that we do for the product. So you could expect something, some update on this on partner source.
Is there also a way to test multi-user scenarios, where the interaction of one user creates errors?
Yeah, so the application tests that we run, they don't test this, not these tests. We have tests running in a performance lab that would, test concurrent activities of concurrent clients. So yes, I mean, you can run these tests from multiple clients at the same time, and then check whether you run into locking problems or similar type of problems. Yeah, so there's nothing that would prevent you from doing that, I would say.
One question, but two parts. How to handle multiple dialog confirmations? I mean, in one test procedure, many dialog, and how handle str many, dialog. The one that is in Code Unit 81, for example.
So when you have multiple different dialogues that are raised in a single test, the way to handle that is if they are of different types of dialogues, so for instance you have a message dialogue and confirm dialogue, then you implement separate handlers for those and attach both of them to the test function. If you have the same type of dialogue but different instances, then there's a way to distinguish between the different instances if the text in the dialogue is different, because the platform will give you the text in the dialogue when entering the handler. So you can, switch case on that text. Then there might be, the same dialogue with the same text multiple times. Then, you could do like a counter to record the iteration. I think I missed the second part of your question.
Dialog str menu. This is the one in Code Unit 81 where it shows what to post.
Okay, yeah. So that's a confirm. No, it's a string menu. Is that correct? Yes. Yeah. So you also have a handler for that. It's another type of handler, and then you can return the option that you select, and you also have access to the text of the options, so you can switch case on that. That's one way to deal with it. In general, how we deal with it is that we look at, if you go just below, so there's one function where this dialog is raised, and then the actual posting routine is called. Right? So you could also call that directly from your test instead of going via the level just above that. And then you avoid that dialog completely, because then you just set the invoice and ship fields on the header directly. That's another option.
Thank you for your very detailed and quick presentation. And I have one question regarding big projects. Let's say you have 10 developers. How many, or should one developer make the test suite himself, or should this be separated? And let's say if you have 10 people doing the development, how many should do the testing?
Yeah, so this is a much debated topic, I would say. So there's different types of tests. When you look at the TDD, test-driven development approach, it's not a testing approach, it's a development approach. So using that methodology, then writing the unit test is really a development activity, and it should be done by the developers. Then there is another level of test that test more of the integration or acceptance level scenarios, and that's done by a QA, quality assurance department with dedicated testers. And I think in Microsoft the rule of thumb is to have a one-to-one relation. I'm looking at Michael. Is that correct? Yeah. So that's kind of the way we look at it.